Hello everyone, thank you for coming for my short lightning talk today. And the topic is the 8 fallacies of distributed computing in practice. I already have seen this topic emerged already yesterday twice on 2 of the talks that I've been attending. And every time I was like, no, stop, I have to leave something for me for tomorrow. So today I will show you some details about this interesting paper. My name is Ania, and I'm originally from Poland, and I've been working as a full stack and backend developer for over 13 years now. Here in Berlin for 5 years. Currently, I'm unemployed. I am employed. Alex Group, which is the biggest internet company that you probably never heard of. We have office here in Berlin. It's like a classified ads platform, but the company does not operate in Germany, so it operates in different countries. You can follow me on Twitter or find me on LinkedIn. All right, let's start. The 8 fallacies of distributed computing. What are these? These are kind of like biased assumptions that all of us unconsciously make, and that can lead to some problems when designing and building distributed systems. And for the start, I have this hilarious quote, which is kind of a Murphy's law. So if one thing goes wrong, everything else will, and at the same time. Hopefully not, but if we are aware of all these fallacies that I'm going to talk about, we can lower the probability that something goes wrong and everything explodes at the same time. So first, a short history class. Here you can see the whole internet as it was in 1973, the ARPA network, so it could fit on one sheet of paper. Only 4 years later, it started kind of growing. As you can imagine, right now we could not fit the whole internet on the one piece of paper. But this was the time that also the TCP/IP protocol was created. But as you already know, TCP/IP stayed the same for all these years. So now we have a huge network and with unbelievable number of nodes, but still have this old technologies running underneath. So, I don't know, this is my opinion, but these 8 fallacies still apply until now. Maybe the scope has changed a bit, but they're still there. So let's start. In 1994, Lawrence Peter Deutsch, or Deutsch, I don't know, wrote the paper about 7 fallacies of distributed computing. He used to work at Sun Microsystems back then, and for those of you that don't know, he's also the creator of Ghostscript. But currently he's working as a music composer because he decided that he doesn't want to have anything in common with software development anymore. But he's quite successful there. And 3 years later, James Gosling, the father of Java programming language, added the 8th fallacy. So now we have all 8 of them. First one is that the network is reliable. As you can see, it's not. Here we can see some most common errors that can be returned by services like unauthorized, not found, forbidden, request timeout, internal server error, and service unavailable. These can be returned by either one of our own microservices or one of the third-party services that are out there. So what can we do? Developers have a huge amount of tools that can help us preventing these errors from propagation. So first, we need to monitor if the errors appear. Then we should do the proper error handling. You can say that this is basic stuff, but still, lots of developers don't care about proper error handling, and then we can end up with some huge problems. Of course, circuit breakers, we already had several talks about it, so I won't go into details here. Along with retries, there are other resiliency patterns that we can also use, like bulkheads. Also queues or caching, so we can, for example, as a fallback, serve cached data that it's maybe not the freshest data out there, but at least we don't break the user experience if something goes wrong in the backend. Latency is 0, of course not. As long as we're on the same computer, for example, we want to access the database, and we have a centralized system, the response time is not very significant. But if we go to the planetary scale, we have to watch, we cannot go faster than speed of light, but if you're, for example, your services are deployed in the cloud, you need to watch out if they're deployed in the same availability zone, for example, in AWS, because otherwise you can have some huge latencies between, for example, your server and database. The third one is about bandwidth. Here I will tell you an interesting story, since I work for OLX. OLX operates in some kind of countries, for example, in India, Pakistan, or African countries like Kenya, Uganda, or Mozambique. And in this kind of countries, the infrastructure is barely existent. So users rely on mobile network, and bandwidth is very precious. For example, you can get your prepaid mobile card as a gift for your wedding or your birthday. So this is very important to compress your data and send, for example, for our customers in these countries, compressed version of the images. So we don't waste the precious network, the precious bandwidth there. Network is secure. Of course, it's not. This is my favorite quote about it that summarizes the only truly secure system is one that is powered off, cast in a block of concrete, and sealed in a lead-lined room with armed guards. And even then, I have my doubts. This is true. What can we do? For example, as developers, we can follow the Open Web Application Security Project Top 10, which is published every year. As you can see, these are the most popular type of attacks that even currently, cross-site scripting is still on the 7th place. So you could think that we got rid of cross-site scripting. No. So this is still one of the most popular vulnerabilities out there. And one more thing, don't ever write your own cryptography library. Just use open source. Topology doesn't change. Here, I will tell you one of my favorite stories, how we treat servers, how we used to treat servers and how we treat servers right now. So back in the times, we used to treat servers like pets. We used to give them names, and if they got sick, we would take care of them. Right now, we treat servers like cattle. We give them numbers, and if they get sick, we just slaughter them. In case of serverless, you could say that we treat them like cockroaches. So it's just like lambda. What can we do? I'm going to tell you my favorite pattern that we do in my company. So don't hard code IP, so it's quite obvious. Use host names instead. Store them in environment variables. Then use them as values in configuration. And for example, you have a microservice which is in a different repository, and periodically you just pull the changes from the configuration repository. In this case, you don't have to roll out the whole application. You just update the configuration, and the application pulls the configuration, the current one, without deploying the whole service. It's a very good pattern, I would say. There is one administrator. In big companies like OLX, there are, of course, more of them. Could look like this. But the most important thing is to communicate well and to be sure that people work with each other on good terms, so we have a proper flow of information. If something changes in the network and it's broadcasted, everybody is up to date, So this should improve the issues that can appear because of this fallacy. And transport cost is 0. Well, we have to watch for our money to not to float away. And of course, the transport itself, if we transfer the data, we should consider the one that is like the bigger one, like XML, maybe something smaller, JSON, and the most compressed, like protocol buffers from Google, which are considered like one of the most compressed way to transfer the data. And if you're using a cloud provider like, for example, AWS, there are some, I could personally recommend this website to compare instances sizes. And always consider switching, for example, in AWS instance from on-demand to on-spot. I have like a story from the last week when we had savings around 80% when switched to on-spot instances from on-demand, so highly recommended. Network is homogeneous. Of course not. This is like summarizes all of it. All of us would like to work with something like that looks like this. Everything is ordered, but in real life, in reality, we have some evil people that mix M&Ms with Skittles, and then we have this mess. And the last words from me is, if you are aware of the 8 fallacies that these problems can appear, this is the first step to fix the stuff as quick as possible. And remember, everything is going to be fine. Thank you.